A cross-tabulation is a special type of pivot table where all the variables in the table are categorical, that is nominal. This is a very important tool in market research and is used all the time to understand relationships between variables. We're going to take a first look at it here and then come back to it later in the course when we talk about statistical tests. Let's take an example of a simple crosstab, what we call a two-way crosstab. That is, a crosstab with just two variables. In theory, a crosstab can have more than two variables, but the data become much harder to interpret, and for that reason they are not commonly used. So we will stick to a two-way crosstab. Let's say Samsung conducted a survey of 600 consumers. The respondents were asked if they owned a Samsung phone, and then Samsung mailed each of them a $20 coupon for a new Samsung phone. Samsung observed how many of the coupons were used by those who already owned a Samsung phone, that is, current customers, and how many by new customers, that is, those who did not currently have a Samsung phone. They then put together this crosstab summarizing the results. The rows show how many people in the sample owned a Samsung phone and how many did not. In total, 450 people in the sample owned a Samsung phone and 150 did not. So the row variable is whether someone is a Samsung owner. The columns show how many people used the $20 coupon and how many did not. In total, 250 people used the coupon and 350 did not. So the column variable is whether someone used the coupon or not. The question Samsung wanted to answer was the coupon more likely to attract Samsung owners or non-Samsung owners, or was there no difference? Well, we can see that 150 Samsung owners used the coupon, while only 100 non-owners used it. So obviously the coupon attracted more Samsung owners, right? Not so fast. Keep in mind that the number of Samsung owners in the sample, 450, was much higher than the number of non-owners, so naturally we would expect to see more of them using the coupon, even if the non-owners were just as attracted by the coupon as the owners. In other words, the base of Samsung owners in the sample is much larger, so we have to adjust for that. So we need to reframe this question as follows. Did a higher proportion of Samsung owners use the coupon compared to non-owners? In other words, if the sample had an equal number of both groups, would we still see more coupons being used by Samsung owners? So let's compare the two groups, Samsung owners versus non-owners, and see what proportion of each used the coupon. Looking first at the 450 Samsung owners, we see that 150 of them used the coupon. So the proportion using the coupon was 150 over 450, or 1/3. Next, looking at the 150 non-owners, we see that 100 of them used the coupon. So the proportion using the coupon was 100 over 150, or 2/3. That's twice as high as the other group. So in effect, the coupon was twice as effective in getting them to buy the product as compared to the other group. So let's summarize what we learned. The question to ask is not how many people in each group use the coupon, but did the proportion of people using the coupon differ in each group? In other words, did the probability of using the coupon differ in the two groups? This will remove the bias caused by the larger sample size in the Samsung owner group. We learned that 1/3 of Samsung owners, 150 over 450, used the coupon versus 2/3 of non-Samsung owners, which was 100 over 150. So we conclude that the coupon attracted non-Samsung owners more than Samsung owners. From the standpoint of Samsung, this was an effective promotion in attracting new users to their brand, which is an important insight for management. Later in this class, we learn how to conduct a statistical test to verify this conclusion. That will allow us to eliminate sampling error as a reason for this result. That is, the possibility that this result was due to an unusual sample. More on that later.